Hi, my name is Randy Roberts. I'm an electrical engineer at the Lawrence Livermore National Laboratory. And today I'd like to describe for you some very cool technology that was developed at the laboratory back in the mid-1990s and then enhanced a bit in the mid-2000s. This technology is called LifeGuard, and it's a precision projectile tracking technology that allows you to actually visualize and see bullets as they fly through the air and then backtrack the bullet or other projectile back to the source so you can find out where the shooter is and you can isolate and locate the shooter. An example we have right here is from our 2005 experiment. Over on the left-hand side, you see a bunch of buildings there, and this is actually a frame from a video camera that we had that was in the infrared. And what we did is we processed that data into the frames that you see over on the right-hand side. Now, what you see here is you actually see a bullet in flight. That's that streak there that's called out in the image. And through correct processing, we're actually able to see a bunch of these streaks as they fly through the air, or the bullets, and we're able to, again, backtrack this to find out where the shooter is. Now, the way this works is that as the projectiles fly through the air, they heat up. They're hot when they come out of the muzzle of the gun or the mortar. They heat the air around them as they fly through, and they make a thermal signature. Now, again, with this thermal signature in the infrared technology, we're able to detect this, and then with the image processing, we're able to isolate the actual streak due to the bullet and suppress the clutter so we can track the bullet back to its origin. Now, I mentioned earlier on that this technology was actually developed back in the mid-1990s here at the laboratory. Here's a clip, not a clip actually, it's a frame from a video that was featured on the NBC Nightly News back in the mid-1990s. And the original idea behind LifeGuard was for VIP protection. The idea being is that if you're a VIP, off to the side you've got a LifeGuard system someplace around you, and what that's doing is that's scanning the field of view, and it's looking for oncoming or any kind of projectile that might be coming in at you, like for example like a sniper or some other kind of a fire like that. And so what the team did back in the 1990s, they were able to actually do a real-time system so they could actually find in real time and locate where the shooter was. That's amazing considering back in the 1990s the kind of infrared technology and also the kind of image processing technology that they had back then. So my hat's very much off to that team. They did an outstanding job. I mentioned that we, in 2000, around 2005 or so, we did another experiment that was by DARPA, and the idea there was a little bit different. What we wanted to do here was we wanted to see if LifeGuard could not look at incoming projectiles, but if we could look out across the field of view of a battlefield and try and find out who's shooting at who and where the shooters are, this sort of thing. DARPA was very interested in finding out if LifeGuard could actually track multiple projectiles in a simultaneous shooting, and if we could also find it in a cluttered environment. And so what you see here in this slide is over on the left-hand side, we've got a schematic of how the experiment was set up. So you can see we've got a building there. We've got an AK-47, M16, AK-47, M16, and then on the ground we had a mortar and a fellow that was shooting a Glock. Over on the right-hand side, you'll see the results we had after we did the processing. So you can see there we've got a bunch of blue streaks, and those are actually tracks from the bullets that we detected. If you look over on the left-hand side of that image where the building is and the shooters are, you'll see those little red air ellipses where all the bundles of the target trajectories, or the projectile trajectories all meet together. And those tell us where the shooters are located in that particular image. Now, the thing that was so nice about this, we were able to get a very, very tight error ellipse on this, which means we were able to find the shooters with a great deal of precision. As you can imagine, the DARPA program manager and the military folks that were helping us out on this experiment were very happy with these results because we were able to find the shooters so precisely. Now, I mentioned earlier that there's a lot of image processing that goes into this. So if you look in the middle of the chart right there, it kind of gives you a sense of some of the image processing that we had to do. And again, LifeGuard is a combination of two things. One is the optical technology that's used to actually detect the bullet, and the second one is the image processing that you use to find it and then to backtrack it to its source. Now here's a close-up of that image that we had there that kind of shows, again in more detail, the results we were able to get out of the LifeGuard. So again, if you look there, you'll see these blue streaks, and those are actually the bullet tracks from the AK-47s and the M16s, the other weapons that were out there. And then over, again, on the left-hand side, you'll see these red little streaks. They're actually ellipses. And that tells us, it gives us the uncertainty as to where we can find the shooter. And again, as you can see, we're able to locate the shooter very precisely, particularly if there's a spread of bullets, which happens in most of the cases. Again, I mentioned that we've got image processing, how that is a key aspect of LifeGuard, and here's why it's key. Now here's another frame that I took from that particular set of experiments that we did. And on the one-hand side, on the right-hand side down at the bottom, you see a bullet in flight. Okay, now that appears as a little streak. But you also see, sort of on the bottom in the midsection, some scene clutter. Now the scene clutter comes and goes depending for a bunch of different reasons why it's there, including thermal effects of the scene and this sort of thing. We actually did this experiment on a hot day in September, and so there were a lot of thermals that you could see on the ground and this sort of thing, and the edges of the building would cause these various kinds of clutters. The problem is that those pieces of clutter from the scene can be mistaken for bullets unless you do the correct kinds of image processing. And that's one thing that we did on this particular experiment, and also back in the 1990s, was to do the right kind of image processing in order to extract the bullets from the scene and suppress the clutter. And what that allowed us to do was to have a very, very, very high probability of detection on this and a very, very low probability of false alarm. Now I mentioned that the idea behind a LifeGuard is to find the locations of shooters. There are other technologies for doing this sort of thing, including acoustic technologies and also muzzle flash detectors. So one thing we did at this experiment is we hung a bunch of pie tins up and let them flap in the breeze, and basically that provided flashes for us that could be mistaken as a muzzle flash. We did this as a way to find if we could how things would work with our false alarm rate. You know, if LifeGuard had a high false alarm rate because of these flashes, muzzle flashes, this sort of thing. It turns out it doesn't. We're able to suppress that away through the image processing. And that's one thing about muzzle flash technology, is that it can be subjected to optical clutter if there are other things flashing in the field of view. The other problem with a muzzle flash is that if you're in an urban environment, for example, the shooter might actually be back inside a building and shooting out through a window, so you're not going to see any muzzle flash there. And the same thing for flash suppressors and this sort of thing. Another kind of technology that we actually had at this experiment was some acoustic technology. And what this did was it basically tried to find out through the report of the gun as it went off, to try and find out where the shooter was. And this technology worked pretty good, but it didn't have the kind of error ellipse that we had in LifeGuard. In LifeGuard, we were able to much more precisely find out the location of the shooter. Now, this brings up an interesting point, though. If you were to take and combine these kinds of technologies, how you could probably do a very, very good job, a very robust job of finding out where the shooters are. So I'd kind of like to end up here talking a little bit about the technology and sort of where it might go. So again, you know, LifeGuard is a proven technology. You know, we tried it out in the 1990s, developed here at the laboratory. It worked then for VIP protection. We advanced it until the 2005 with the DARPA experiment. Again, had phenomenal results, really excellent results. We're able to track multiple shots at the same time back to the shooters. Very low false alarm rate, excellent results. And so it's a very, very good kind of technology. Again, combination of sensor technology and the image processing. Now, so where do we go from here with the LifeGuard? One thing that's very interesting is that we did some modeling, and it looks like we might be able to build a LifeGuard using some very simple sensor technologies, like what you see over there on the right-hand side, that little bitty camera there that someone is holding in their hand. The cameras that we used previously were actually science-grade cameras, but again, through some of the modeling that we've done here at the laboratory, it looks like what we can do is to find and to use very small cameras for LifeGuard. That's a very exciting and very interesting possibilities. Okay. Now, some potential applications or sort of paths forward for LifeGuard would include doing 3D precision tracking. Okay. Now, the idea here is if you had a couple of LifeGuard systems off looking out into the distance, how you could triangulate and find out where the shooter is in 3D. Okay. Another thing that was actually tried out in the mid-1990s and found to be very successful was tracking mortar fire. Okay, now there's a couple of nice things about this. For example, if you were at a forward operating base and you're being subjected to harassment fire, you could have a LifeGuard system there, for example, that could be scanning the horizon, and when it detects a mortar coming up, it could estimate what the trajectory of the mortar is, and it would be able to tell you and give you fair warning as to where the mortar is going to land. That could be a very, very powerful technology for our folks out in the battlefield there. And finally, I'd like to describe one other kind of application that, again, uses the small, miniaturized technology. It could be very, very interesting, and that is to take these little cameras and to mount them on UAVs, for example, or to mount them on soldiers. Like we see in the very bottom there, that bottom image over on the right-hand side, we've got a soldier there in the middle that appears to have some sort of a camera system on his helmet. And you can imagine if you had a squad or something like that with these kinds of sensors, how you would have a mobile network that would be moving around. And they would be wirelessly connected, for example. And so if they're down in some sort of very cluttered environments as we have here, they could be moving about, and if there was a shooter someplace around and you had the system on more than one helmet, you could triangulate on that and do it in a very fast and efficient manner. And that could be a very, very interesting application right there. So I'd like to wind up by saying, this is Randy Roberts at the Lawrence Livermore National Laboratory, and if you have any other questions about this technology, please contact Henaro Mempan at the email address listed below, and he can set you up, and if there are technical questions, Henaro can send them on to me and I'll get back in touch with you. Once again, thank you.